Hi, next is your Zener diode. Zener diode basically works in reverse bias. So when you connect a diode, this is your reverse bias. Okay. So initially the current will passing through this diode will be very small, almost negligible. But once you start increasing this potential difference, or you can say this negative potential, this diode will break down and then large amount of current will start moving across the diode. So that potential, what we have applied here, will be known as Zener potential or breakdown potential. Now, as you can see from the curve, I'm talking about this part. Okay. Here, this is the negative potential we have applied. Once it is applied in reverse bias, then a large amount of current starts flowing across the diode. Next is your working of Zener diode, but before that, we'll understand how how this much large amount of current starts flowing. So in the Zener diode, we know there will be a depletion region. Okay. Now, within this depletion region, there will be a strong electric field. Once we connect it in the reverse bias, we know this depletion region will increase. As the depletion region increases, the more number of atoms will be exposed, okay, and then more stronger electric field will be produced. If this electric field is very strong to remove the electrons from the atoms, so let's say this, due to this electric field, one electron has been removed, then due to this electric field, this electron will start moving along this direction. So when this happens, there will be current current which will start flowing, okay. So this is your how a Zener diode works. So at the Zener potential, the electric field is strong enough to remove the electrons from the host atoms on the p side, which are getting accelerated towards the n side. Next, these electrons that these are the electrons that contribute to large reverse current in reverse bias at the Zener potential. Next is our working of Zener diode as voltage regulator. A few things you have to remember here, that when we are using Zener diode as voltage regulator, it has to be connected in reverse bias. Okay. Okay. The second important property here is, as you can see from the curve, once this breakdown takes place, then large amount of current will start flowing, okay, across the Zener diode, but the potential difference across Zener diode will remain same as Vz. Okay, so we can write the second point here. Uh, at Zener breakdown, potential across Zener diode will remain same, and current will start passing through it. Okay. So this is your circuit diagram. Here we will connect a battery like this. Okay. So we are supposed to connect it in reverse bias like this. Okay. Now this is your let's say battery here, or let's say you have to charge your cell phone battery, or this is your resistance here. Somehow we don't want the potential difference across this resistance to increase. Just giving example, let's say 2 volt. We don't want potential difference across this resistance to increase more than 2 volt. Okay. So initially, let's say we have connected a battery. Once we increase the potential difference of battery, the potential difference between these 2 points will start increasing. So when the potential difference between these 2 points start increasing, We can say the potential difference across these 2 points will also start increasing as more amount of current will be flowing through this resistance. Now, at a certain potential, this Zener will break down. So let's say we have chosen the Zener breakdown potential as 2 volt. Means when a potential of 2 volt is applied across Zener diode, it will break down. So once the potential across this Zener diode reaches 2 volt, this will break down. Once this thing happens, the potential difference across Zener diode will remain same. So we had our load here. Once the Zener diode breaks down, the potential difference across this resistance will remain same as 2 volt. No matter how much you increase the potential of this battery here, the potential difference across this resistance will remain as 2 volt. So basically we have protected this resistance if let's say there is a lot of voltage fluctuations. So in any case, the voltage difference across this resistance in this situation won't decrease 2 volt. So once the breakdown happens, then large amount of current will start flowing through the Zener diode, and our this resistance will remain protected. Potential difference across it won't reach than more than what we require. So this is the working of Zener diode as a voltage regulator. Okay, thank you.